Okay. Example 3 says, so today we'll cover some of the negative ones. So this is just a refresher of what we did yesterday. This is find the terminal point on the unit circle determined by the following value of t. So the question is, if we walk pi over 4 units, a distance of pi over 4 around the unit circle, what is the terminal point that we're brought to? So you want to be able to do this. Okay, Jack is right that it is a 45-degree angle, which we will use. So if we walk that length, that's pi over 4. Jack is right, we get a 45-degree angle. Okay. Have a difficult time. I should make my notes bigger. It's just trying to fit it in that space. Now, a lot of you guys might go to the chart right above you and say, well, I can see that pi over 4 already has a terminal point decided for it. Well, you don't want to have to go to that. You want to be able to construct it on your own, because you're not going to always have that in front of you. That chart won't always be there. Okay? Classic example of AP Calculus. You don't get a chart as you're taking that test. College, you may not get any type of notes when you're taking that test, and they ask you what the sine of pi over 2 is, and you don't know. The sine of pi over 2 is 1. How do I know that? Because I constructed. So we're going to incorporate sine and cosine on Friday or on Monday, and you're going to have to use these things in the future. These don't just go away. These are the fundamental building blocks of trig. No, you do not get this on the test. Okay? You will construct it and find the values. Okay? So, as I make that, what is, if I'm in the unit circle, what's the length of the radius or the hypotenuse? 1. And so yesterday we worked with the 30, 60, 90 and 45, 45, 90 to find that the length of this side is then going to be what? Square root of 2 over 2, because you take 1 and divide it by the square root of 2 and, reduce the denominator, rationalize the denominator. And since it's 45, 45, 90, they're both the same. So the terminal point is a square root of 2 over 2, comma, square root of 2 over 2. So that should be reviewed from yesterday's assignment where you did the the worksheet, okay? Yes? All right, so 4 pi over 3, we convert that to degrees. What would it be? 240 degrees, so you know how far you should go around. $240 degrees is right there. You always draw the leg of the triangle to the x-axis. Always draw it to the x-axis. Never, ever, ever to the y-axis. All right, so how many degrees past 180 did we go? 60, okay? So you know that's 60. What is the length of the hypotenuse or radius? 1. The shorter side is 1/2. How do you get the longer side? Times by the root of 3. So you have the root of 3 over 2. So which quadrant are you in? Third. So the values are both going to be negative. Very good. So we have negative 1/2. That's the horizontal distance. And negative root of 3 over 2. That's the vertical piece. What do you think? Okay, let's add in a negative problem. So on your assignment yesterday, you had some negative ones. You're wondering what to do for that. Negative just simply means we rotate in the opposite direction. Okay, please follow along so you can understand why this is the way it is. If I start here and I walk around the circle back to that same spot, how far have I traveled? 2 pi. 360 is the angle that I have turned. I'm wondering the distance I have walked. And so the walking distance is 2 pi. All right? Now, if I start here and I walk in the other direction all the way around, how far have I walked? Negative 2 pi. So just like we labeled 0, pi over 2, pi, 3 pi over 2, 2 pi yesterday, today what we can label if we have a negative 1, we can label 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Does that make sense? So therefore, negative 3 pi over 2 is in the same position as 5 pi over 2. I'm sorry. Negative 3 pi over 2 is in the same position as pi over 2. Okay? Those are in the same spot. Now, if you're going to go negative 5 pi over 6, you tell me when I've reached the spot. Yeah, somewhere right about there, because 5 pi over 6 is how many degrees? 150. So you're going 150 degrees in the opposite direction. So how many degrees short of 180 am I? 30. So this is a 30-degree angle right there. And so we have a 30, 60, 90. And so you know the hypotenuse is 1. You know that this length is 1/2. Be negative, and then this is the square root of 3 over 2. You're in the third quadrant, so both values will be negative. So you have negative root of 3 over 2 and negative 1/2. Now, the last thing I want to state here is that negative 5 pi over 6 is in the same position as what positive 1. Which positive radian is in that same spot? 7 pi over 6. So 7 pi over 6 and negative 5 pi over 6, some of your brains are already working towards that. You're like, oh yeah, negative 5 pi over 6, that same position is 7 pi over 6 if we go the other direction. Some people just convert them to the positive 1 right away. I'm not expecting you to do that yet, but 7 pi over 6 and negative 5 pi over 6, those are what we call coterminal. They share the same terminal point. In fact, there's an infinite number of coterminal angles. If you heard me say that negative 3 pi over 2 is in the same position as 5 pi over 2, it is. 5 pi over 2, it's also in the same position as 9 pi over 2. You could travel around the circle more than once. You have an infinite number of rotations then, and an infinite number of points that pop up. So, also infinite in each direction. So, thus we may map all the positive ones on the x-axis forever going one way, and all the negative ones on the left part of the x-axis going the other way. Okay. So, all right, we try the bottom part. Okay, so this is the last thing that we want to do for the day, and this is regarding your reference numbers. And reference number is not something that's going to make a lot of sense today. You're going to be, why do we use this? Again, we're at the building blocks of trigonometry. This is something you will eventually use. Note that I want to get you guys to a point where you can solve 4 cosine squared of x plus sine of 2x is equal to 5. That's a very complicated equation to solve, but I'd like to get you there. In order to do stuff like that, we gotta do some basic building blocks ahead of time. Okay. So we move to this example. Reference number: the shortest distance between the terminal point and x-axis. By the way, the only reason I was nominated for Teacher of the Year is because I paid Miss Nelson to do it. So, say give you $5 if you nominate. That's what it works. What? I just wrote the letter for her, and then I had her sign it. So, yeah, I know. And I'm gonna win. All right, okay. Oh gosh, good times. Okay, our joke is that they're at the G's this year, so being against, so that just can't go through the order. All right, 2 pi over 3. How many degrees? How many degrees? 120. So if you consider my rotation, this is pi over 2, 0, pi, 3 pi over 2, 2 pi, so on and so forth. Okay, kind of my rotational pieces. And I rotate 2 pi over 3. I walk around the unit circle 2 pi over 3 units. As Larissa said, that brings me to, rotation about 120 degrees, okay? Now, when I said the shortest distance, so that red dot, that's my terminal point. The definition of a reference number is the shortest distance from the terminal point and the x-axis. So I could walk from the red point along the red line, or I could walk along the green line. Either way, I'll get to the x-axis, which is the shorter distance, the green. And so what we do is, this is 2 pi over 3. I take the shorter distance and subtract it from the larger distance. So which is larger, pi or 2 pi over 3? Pi. So I take pi and I subtract 2 pi over 3. What's pi minus 2 pi over 3? Yeah, that's 3 pi over 3 minus 2 pi over 3 is 1 pi over 3. So pi over 3 is my reference number. I could give you, for example, if I give you a reference number, or if I give you a measure, 7 pi over 6. The reference number is 1 pi over 6. They all have a relationship. In this case, the reference number for 2 pi over 3 is pi over 3. Let's look at a little bit more complicated example. What do you notice about B? There's no pi, and that's all right. Remember when you're in geometry and sometimes you express things in terms of pi and sometimes you wrote it as a decimal? It's the same thing in trigonometry. So if you were to walk around the circle, I could express this as 0. If I walk all the way around, it's 2 pi. Express 2 pi as a decimal. 6.28. If I walk to here, it's pi. Express pi as a decimal. 3.14. So pi over 2 would be 1.57, and this would be 4.71 approximately. So if they say walk 4 units around the unit circle, which quadrant is that going to bring me to? Third quadrant. Somewhere right about there, right? So I'm going to walk from that point to the x-axis. So I can either take the green route or I can take the blue route. Which route is shorter? Green, right? Right? No, it's okay. We all make mistakes. But Emma, you do see why it's green, right? Yeah. So it's not that green goes all the way down around to the beginning, just to the x-axis somewhere. So this position right here is 4. So I'm walking from 4 to 3.14. So I subtract them. The larger, I subtract. So I do 4 minus 3.14. What's 4 minus 3.14? 0.86. So 0.86 is my reference number. Now that's not one I just do in my brain. I generally write it out. I'm not, my brain kind of works with the pies, Yep, who doesn't? Love apple. Love apple. Probably the best. Yep, warmed up with some ice cream. Oh, boy. All right, last one. Almost out of time. I got a minute 15. So now I got negative 3.62. If you go negative, this would be negative 3.14, negative 6.28, negative 1.57, negative 4.71. So if I go negative 3.62, which quadrant is that going to bring me to? It's going to bring me to the second quadrant, right about there, negative 3.62. Do I travel the green route or do I travel the red route? I travel the green. And so what you'll do is you'll take the larger number. What's larger? Negative 3.14 minus negative 3.62. And so when you subtract them, you add the opposite and you get 0.48. Here's your assignment. Write down. Finish up that worksheet, and there's your assignment. We'll see you tomorrow. Time flies when we're having fun. Tell me about it. Love me some mathematics, right?